Okay, so hi everyone. Welcome back to the Ignited Minds channel. Today we have environmental scientist join here with us. And so, do you want to introduce yourself to everyone?
Sure. Hi, everyone. My name is Reddy Yatavelli. I'm an environmental scientist at the California Air Resources Board. It's a state agency that regulates air quality and climate change for the state of California in the United States.
So, what inspired you to become an environmental scientist?
One of the first things that happened was when I was a graduate student. So I was doing my master's. Um, and I got an offer to go measure the air pollution in Ohio. So Ohio is quite polluted in some areas because it has large power plants, coal power plants mainly. And when you burn coal, you get a lot of smoke. And in the smoke, there are a lot of chemicals. And also, there's something called particulate matter, which is also bad for the air and also people. So I was started working measuring the pollution in the air, and I got really excited when I started measuring some of the chemicals using advanced instruments. And I didn't know until then that there are all these chemicals in the air that we're breathing. And this was in South Ohio, where there are a lot of coal power plants. And that's when I started realizing that the air can be polluted in some parts of the world where you do have a lot of pollution, and they can impact human health. So it can impact people's health, it does impact animals, and also it impacts agriculture and forests. So that's what started me. I got excited about that, and I wanted to do more work and understand what happens when you actually have chemicals in there, because there are a lot of chemical reactions that are happening in the air after the chemicals are produced and they are in the air. Then they get transferred because you have wind blowing all over. So as the wind is taking these chemicals, they react because there's sunlight, there's other chemicals in the air. And so I really got interested in understanding the chemistry of the air pollution. And of course, one part of that is air pollution also impacts on one is health. It also impacts the earth through climate change. And so I got interested both in air pollution and climate change. So I went and did my PhD in that later.
So, in all your work so far, what's the most surprising thing you've learned about the environment?
Yeah, one of the things that I got really surprised by is this was later in when I started doing my PhD. I was trying to build an instrument to understand the chemicals in particulate matter, and I described particulate matter earlier or mentioned it. So you have a lot of gases. So these molecules of different, so like you have oxygen, you have hydrogen, they mix sulfur, and there are a lot of other gases. So these are just molecules floating around in the air. But what happens is particulate matter is where all these molecules come together and form tiny particles. And that's what, if they're big enough, then you can actually see them, and that's what blocks the sunlight. Um, and some cities, especially in Asia and Africa, South America, you actually see in big cities, it's hard to see the sky, and that's because these particulate matter or those particles actually block the sunlight, so you can't really see the blue sky that's out there. You don't see it until they all wash out after a rain. So when you have rain, just after rain, if the skies clear up, then you can actually see the blue sky. That's because the rain has washed out all those particles. So going back to your question, what was really surprising to me was those particles are made of chemicals. They can be different kinds of chemicals, but the surprising thing was those particles can have thousands of chemicals in them. They have carbon, hydrogen, sulfur, nitrogen, but those tiny particles have thousands and thousands of chemicals. So for me, what I was trying to do was I was trying to design a machine and build a machine that can understand a certain portion of the chemicals and try and understand how the chemicals actually even got there in first place. So I started out on trying to understand the chemicals in the gas, as the chemicals that are in the gas. Look, an easy example is carbon dioxide is a gas. Carbon monoxide is one of the pollutant is a gas. But when you go to particulate matter, they can actually have thousands of chemicals on them. So that was the most surprising thing to me. And they're bad for your health. So when you go to the health impacts, actually when you breathe these chemicals, some of the chemicals actually start burning your lungs. But these particulate matter, you actually breathe and they actually go into your lungs and they can damage your lungs. And that's the health impact.
So you mentioned like using different type of instruments quite a bit. So can you like give us some examples of instruments and like how you use them?
Yeah, so there are different instruments depending on what you're trying to understand. One is again broadly there's chemicals that are in the air just as molecules. So those called gas phase molecules. So phase is just what form they are in. So in the gaseous form, you have some chemicals. You have some chemicals that are in the particle form. So the particulate matter. So when you're trying to measure gas phase, there's different ways to understand the chemicals or measure them, and it depends on the chemistry of the molecule. So I mentioned carbon dioxide. Carbon dioxide, when you look at the chemistry or the molecular structure, you have one carbon and you have two oxygens, and those carbon and oxygen molecules they come or atoms they actually come and combine together in a certain shape. So it's actually it looks like V.
Yeah.
So there's a carbon in the middle and then there's oxygen. They form a double bond with oxygen. But what happens with these molecules is depending on the energy, these molecules vibrate, they rotate. So what you can do is what scientists have figured out is how to use this structure and the vibration or rotation of the molecules to measure these different chemicals. That's just again one example. So for carbon dioxide, when you have energy come and hit the molecule, it starts vibrating more, or it does something else. And then scientists try and understand, okay, how much energy did I inject, and how much energy did the molecules absorb, or how much is lost. So you give some x amount of energy and then you measure how much energy was lost, and that tells you how many molecules are there. So that's one of them. The other one is depending on, so some molecules they actually absorb energy, and as you learn in chemistry, in especially in high school, there are different energy levels for different molecules. So when a molecule absorbs energy, it goes from one energy level to a different energy level. Around the it depends on the atomic structure, but it goes to a different energy level. These are called discrete energy levels. And then, but the molecule has energy. It cannot stay there. It wants to come back to this lower state. It's called the ground state, which has less energy. But in the process of coming back, these molecules emit a photon. A photon is nothing but it's a light. So if there's a lot of molecules and they all want to come back, then there's a lot of light that's coming out, or they're emitting a lot of light. They're emitting a lot of photons. So what scientists have figured out is, oh, maybe we can measure the light intensity, and that tells you how much of that certain chemical is in the air. So that's a different form of measurement. There's a lot of other different measurement types. When you go to measuring particulate matter, one of them is just understanding how much particulate matter is there. So measuring the mass. So what people do is, like in your homes, you have filters. So if you have a lot of pollution, you have air conditioning system, it's going through a filter. And the filter is there to collect all the dust, all the particles. So scientists have figured out maybe we can do the same thing to measure the particulate matter. So what they do is they take a lot of air, they suck it through a filter, and they try and measure that after a certain amount of time. And that way they can measure the weight of the filter. How much was it before without the particulate matter? How much was it after? And they'll tell you, say, if you collected the air through the filter for 24 hours, it'll tell you how much particulate matter was in the air over a 24-hour period. But that's a basic measurement. There are a lot of other measurements. And an example that I gave was, as a PhD student, I was trying to build an instrument to understand the chemistry or chemical composition, not just the mass, but actually what form, what chemicals are in the particulate matter. So there's a lot of chemical instruments that you can actually, once you collect the filter, you can actually take it to the lab and you can understand the chemistry of those. And there's other types, but those are the general ones.
So what role does like climate change play in your work?
So anytime you use energy, depends on again what where the energy is coming from, or what human activities are around. Say, let's say you're going to buy to a market. You want to drive a car, and anytime you're going in a car that actually burns fuel, it creates a lot of chemicals. It produces a lot of chemicals, and one of the main ones is carbon dioxide. Because of when the fuel gets burned in a car in an engine, um, carbon dioxide is one of the main products. And carbon dioxide, as I mentioned, it absorbs, and the shape is like that. It absorbs energy, and if you think about it, you have a lot of energy coming from sun, and there's a lot of energy from Earth going back into space. So what happens is, as you increase your carbon dioxide in the air, so people burning more and more, driving more and more, burning more fuel, burning forests creates a lot of carbon dioxide. A lot of industries burning coal, a lot of coal power plants, even industries burning a lot of wood. They all make carbon dioxide. All of that is going into the air. And what has happened over hundreds of years now, especially after industrial revolution, um, the carbon dioxide concentration has gone up. And there's a few other chemicals that are even more stronger greenhouse gas. They're called greenhouse gas agents, but carbon dioxide is the main one. They stick with that. What happened is carbon dioxide concentrations has gone up in the atmosphere, and that doesn't allow. What carbon dioxide does is it absorbs the energy that's going out into space, and it reflects back to Earth. So slowly, the energy stays around the Earth, and it has been increasing the Earth's temperature. There's an equilibrium temperature for the Earth, and increasing carbon dioxide concentrations have increased the average temperature for the Earth. And so for us, in my work, what we do is we try to regulate the cars and trucks and buses that are driving on the road. So every car, truck, or bus that's driving in the United States has a limit on how much carbon dioxide and other pollutants you can emit, or that engine can emit. And if that truck or bus or a car emits more than what it should, then what we do is we go to the manufacturer of that truck or a car or a bus, and we tell them that they need to fix something on that. Or one of the other things is we actually do put a fine on the manufacturer of that car or a truck, and then that forces them to make their cars and trucks efficient and reduce the pollution in the air. And that's one aspect that my agency, the California Air Research Board, has been doing for 5 years, 50 years now. And then there's for the whole United States, there's United States EPA does something very similar. And what we've done, especially at my agency, what we've done is we've actually pushed the people, like just any Californian who wants to buy a car, we are trying to provide incentives and push them towards buying EV trucks or EV cars. Because in a battery electric or a fuel cell electric vehicle, you actually don't burn any fuel. You actually charge the vehicle, or you actually use hydrogen in a fuel cell vehicle, but you don't create all the pollution. You don't create carbon dioxide, you don't create carbon monoxide and some of the other chemicals on the vehicle. Of course, you have to charge the vehicle. If it's a battery electric vehicle, you have to charge it. You can charge it at home, and the electricity is coming from somewhere. But that's a different thing where you do, if the electricity is coming from coal power plant, then you do make a lot of carbon dioxide and other pollutants. But if it's coming from clean sources, say wind or solar panels, then it's pollution free, partly again, because making solar panels also creates carbon dioxide. But you're trying to reduce the whole air pollution and climate change aspects of the traveling, the industries, just the human behavior.
So, if people wanted to make like one small change in their lives that would have like a big impact on the environment, what change would you like suggest?
One change is use less energy. So
Mhm.
as you're going around the home, if you see lights kept on or any electronics that's plugged in, you're not using them. Even electronics plugged in do consume small amount of energy. So if you're not using any electronics, unplug them. If you're not using any lights, if you're not using water, just turn the tap off, turn the lights off. That's just a simple thing. So using less energy, wherever the energy is coming from, it does save money, but also it does save, um, um, it does minimize the pollution. The other thing you can do is, if there's opportunity, walk or bike, rather than using a car, because that anytime you take out a car and drive a car that does use fuel, it could be petrol, it could be diesel, you burn and you make pollution. But if it's close enough, then you can actually walk or a bike. Or what you can do is you can combine all your trips into one trip. Um, Thinking about all the things you have to do when you are going out of a market or a grocery store, or maybe going to go do something else, you can combine all the trips rather than going every time. And that actually saves you time, saves you money, of course, because you're burning less fuel, but also helps the environment by creating less pollution.
So, for like students that are interested in following the same path, what skills or classes would you recommend to help them that
Yeah,
helped you the most?
yeah. And if students are in high school or middle school,
Mhm.
you do want to learn math because mathematics is fundamental. You want to understand your mathematics really well, concepts, because
Mhm.
these concepts are used everywhere in science.
Yeah.
Um, then definitely understand if you have an opportunity, learn the physics and chemistry aspects. So math, physics, and chemistry are fundamental. Um, and from there, when you go to into say college, you can actually choose. You can go into chemistry, you can go into physics, you can go into pure math, you can go into engineering. Any of these fields will help you get into, say, environmental sciences. You can become a chemical engineer, mechanical engineer. All those fields are used, and all those expertise are used in trying to reduce pollution.
So, like, what advice would you give to them other than classes to take?
Yes. Other than classes, I would say think about if you have the opportunity, look around you and see if there's a project you can do to understand some of the concepts. As you going out, if you do smell something on the road, ask a question: Is where is that smell coming from? Is it coming from a car or a truck that's driving by? Is somebody cooking something? Because when you cook something and you see some smoke coming out, say, are you doing a barbecue? That's chemicals. So always question, have that curiosity to know when you look around what's happening around you. Clouds, understanding wind, um, understanding rain, all of those, because all of those combine to understand the earth. If you have opportunity to go to ocean, think about ocean. Think about the waves that are forming. Think about the pollution in the ocean. So anything that I think the fundamental thing is being curious to understand things, question everything. Is there a better way to do it, or what happens if I don't do it this way, but maybe do it other way, or if that's an opportunity that you have. So asking the question, being curious, and learning, because now with everybody having internet, there's an opportunity to ask a question and try and understand. Um, and if you have the opportunity, do some projects, um, do some simple projects at home, or through as a school group. If that's an opportunity, think about a project that you want to do.
So what's a challenge that you face in this field?
One of the challenges, one of the big challenges is changing human behavior, because humans have evolved over especially the past few hundred years since industrialization, to use more and more energy. We have a lot of devices around us, and it's hard to plug away from the devices. And it's very easy to take a car to go somewhere rather than taking a train or a public transportation.
Yeah.
and changing that behavior, because anytime, as I mentioned earlier, anytime you take out a car that's burning fuel, makes pollution.
Mhm.
So if there's opportunity, maybe 3 or 4 or 5 people can carpool together if that's an opportunity. Or if you have buses and trains, you can take the bus and train, public transportation. But it's hard to get away from the human behavior, because small changes, again, as I mentioned, small changes actually do make a big change. But human behavior is one of the hard things to change. And it takes time.
Mhm.
People are realizing more now. Air pollution is a big problem. Climate change is there, but also water pollution, pollution in the oceans is a big problem. So everybody is learning, but I think it's an opportunity for people in high school, colleges, to think about this problem and educate people around you. That's one of the first things you can do is you can educate your parents, your uncles, aunts, everyone. If they don't understand a problem, then or maybe talk to them, and maybe you can make a small change, but that is a change in the right direction.
So looking from like a bigger perspective, how do like governments and scientists like work together to solve like environmental issues?
Hmm. Yeah. So our example is our agency is a science agency. We are part of the government of California, but
Mhm.
most of the people that work in our agency are scientists and engineers, and we are trying to figure out ways that we can reduce air pollution and minimize or mitigate climate change. So what we do is we think about the regulation that we can bring to, say, make a car or a truck or a bus cleaner. Yeah, of course it does take money, because if we do put a regulation saying you cannot produce CO2 when you burn fuel, then the manufacturer of a truck, or maybe some new company that wants to bring in a truck or a bus, they have to think about ways to create the car cleaner, or produce a car, design and produce a car cleaner in a cleaner way. And that takes money. So that's where the scientists and engineers who are focused on trying to reduce air pollution, and the governments who can make a regulation come in, because then the governments can make a regulation or a rule saying that in this part of the country or the whole country or even the whole world, we want to tackle this problem, and we want to make sure that we are reducing the air pollution or climate change in a certain way. But always there is money involved, because people work in industries that make cars.
Yes.
People work in industries, farming, or any other aspect. So what governments are trying to do is trying to balance the economic impacts,
Mhm.
and trying to at the same time come up with laws that will help the future, reduce the pollution, mitigate the climate change. But at the same time, again, you want to have good jobs and good economy, and that's where the governments come in.
Yeah. So what's in your opinion, what do you think is the most like urgent global environmental issue right now?
I think the most urgent issue is definitely air pollution.
Mhm.
And United States has done a lot of work over the past, again, 50 years, 5 decades, to reduce the pollution. And it took 50 years, but there's still areas, especially where you have a lot of pollution, say ports. Say we live in Los Angeles, so there's a
Yeah.
big port in Los Angeles and Long Beach. And anytime ships come in, they do make pollution, and the trucks transporting a lot of the goods, say from the port or to the port, make a lot of pollution, and the communities around there are impacted by the pollution.
Yeah.
Communities along highways, if there's homes really close to highways, you actually do see that those people get impacted or get exposed to air pollution. But overall, the United States has done a good job. But if you go to Asia, say India, China, or say some of the other countries in Asia or Africa, um, you actually have a lot of industries that are not regulated yet. You also have your cars and trucks that are getting cleaner, but not yet to a point where it can help the environment. You also have a lot of burning. Trash is burnt everywhere if you go to Africa and Asia. So if there's an opportunity, not burning trash actually helps the environment quite a bit, because people in cities actually suffer with a lot of air pollution problems, health problems because of air pollution. That's That's partly because of the trash burning that happens everywhere in Asia and Africa. Um, so um, so that's for the rest of the world. We don't see that much in US, but one of the other things we do see now in US and Canada that's happening more often is forest fires. Forest fires do create a lot of smoke, a lot of particulate matter, and a lot of people are impacted by the smoke because the smoke can travel across the US or across the continental US, and that does impact. So again, scientists are trying to figure out how to mitigate the impacts of forest fires or how to control forest fires. But unfortunately, because of climate change, we've seen more and more fires now,
Yeah.
just because the forests are impacted, and there's a lot more dry trees, dead trees.
Mhm.
That's creating large fires. So there is different things, but at least on the small scale, I think we need to tackle air pollution. And climate change is a much larger problem.
Yeah.
It's a long term problem. It's a problem for say kids in high schools, colleges,
Mhm.
um, to think about this, but also force your parents, your uncles, if you have the opportunity to talk to um, your legislators. So the people who are making laws, if you have the opportunity to talk to them, send them letters, make phone calls, tell them to tackle climate change because it's a long term problem, and we need to keeps keep coming up with solutions that create or reduce the climate change,
Yeah.
or mitigate climate change.
Mhm. So how do like environmental scientists make sure that like their data, their findings actually lead to real world like change?
Yeah. So one of the things that we do is, of course, when we do measurements, if it's a air quality measurements, then there's
Mhm.
a lot of procedures that we have to follow to make sure our data is accurate.
Yeah.
Um, and we spend a lot of time trying to make sure that our data has the quality and accuracy um, of to really make sure that the data that we're getting is can be presented to someone, and along with uncertainties, because anytime you make a measurement, you measure something, but also there is small uncertainty involved with that measurement. So what scientists try to do is we try to understand the measurement and the uncertainty along with that, and that's what's then it's presented at conferences, it's presented at meetings. There's a lot of debate that happens among scientists on if the data is accurate or not, because you do want independent scientists to review your data. So there's a lot of publications, scientific journals that the data is submitted to, and scientists write papers. Um, and after all of this, if there is problems that we do see that can be solved, then we go to the regulators, talk to the regulators, people who make laws, and then we show them the data, and then the regulators take on and say, okay, how can we do this? And that's where our agency comes in, is we take the science, we take the engineering, and we come up with laws that minimize air pollution and minimize climate change, but work with the industry, work with the car makers, work with the industries, and think about, okay, how far or how long does it take to um, reduce air pollution or climate change, so you don't have negative impacts or your health gets better, say in a state or a country. So it's a slow process. It's everybody's in together. Even industries are in this because there are a lot of new technologies now that come out of startups trying to solve this problem. So it creates jobs. It creates, people call it high tech jobs, um, but it does create opportunity to have new industries that solve the problem. And a good example, if you've heard about a company called Tesla.
Yeah.
So Tesla was trying to solve a problem where you have a lot of air pollution created by cars driving around. So with an EV car, now you actually don't have create pollution while you're driving. Again, as I mentioned earlier, you do have to charge the car, but Tesla is one of the good example. It, it, it made EV cars look really nice, and
Yeah.
people did buy a lot of EV cars,
Mhm.
and that's one of the policies of our agency, our state government of California, that provided the funding for Tesla early on, because we want to make sure that industries like those succeed.
Yeah.
And because of that, we actually have less air pollution.
So finally, how can young people like preteens, teenagers contribute to solving like environmental problems?
So I would say, again, start with your home, start with anything that you are doing. Think about what impact it has on the environment. Um,
Mhm.
as you're walking by, you education is one of the other things. Is talk to your younger siblings, talk to your parents, uncles, aunts, anyone you can talk to, teachers, and do some projects. Try and understand the concepts, because right now what you can do is you can build your knowledge by learning some of the fundamentals on math, physics, chemistry, wherever you get an opportunity, and then as you go in your, say, in your life or in your career, as you go into college, then you can start thinking about which areas you want to tackle or which areas you want to help. You can go into engineering, build some of the products like Tesla again. You can build cool cars that don't pollute, or you can go and make some chemicals that might actually help the environment, or reduce the impact of climate change. The other one is big water pollution. How can we minimize plastics? Um, so using less plastics is actually overall good for everyone. Um, so so think about small ways right now. Focus on your education, learn the basics, be curious, ask questions, and educate everyone around you, along with you, yourself. And if you actually have opportunities, again, as I mentioned, in the school or at home, do some science projects, simple projects trying to understand the concepts. Um, and I think that will help you get better at just how you ask questions and what kind of questions you want to ask, and your curiosity, it'll improve your curiosity, but also it'll help you get into a college or an education that will lead you into environmental, say, sciences, or overall in the field where you can actually make an impact.
Thank you so much for sharing with us today with Ignited Minds, and I hope everyone watching enjoyed. So, and definitely if you're interested in environmental science, make sure you educate yourself and others. So,
Yeah,
thank you.
thank you. Bye.